Hi, let's discuss completely about an inclined plane. What is an inclined plane? Inclined plane can be anything that is inclined to the horizontal. A good example is what? A staircase. A staircase has a certain shape. See? So it is an inclined plane. Or just a certain slope, whatever slope of a mountain or anything like that. So, a simple thing like a chisel is also an inclined plane. An axe, an inclined plane. Anything that is soft has this type of shape supposed to be an inclined plane. So we are just about to look at basic simple features of forces, how the forces are acting on an inclined plane. Now let's just go at look at this one. This is the horizontal line and there is an angle of theta over here and the inclined plane is there and there is a weight for mass that is mounted on here, that is the object. So the object can exert the gravitational force, that is the weight of it. So it's mg, simply directly downward. So you can make a 90 degree, that means a perpendicular angle with this one, with the horizontal. And have a good look at here. Then you have marked another force, that is the reaction force exerted by the object on the plane is marked as R. Now I have to resolve the forces. How would I resolve these forces? It's simple. Before that, I have to mark and complete this one. What is that angle? The angle is nothing other than 90 minus theta. That is 90 minus theta, because according to triangle you have only what? 180 degrees remaining, and already 90 is given. That's the theta, and this is 90 minus theta. And it's my aim to find out and resolve for this mg. Have a look at the mg. You have to find out the r component in terms of mg. How to find it? It's really simple. So you have to find this r component and you have to just resolve this force into certain perpendicular things according to that one besides this one. So the other force is this one. We still don't know what is that one or this one even. So how to resolve? The angle is over here, but you can see very simple and important thing here, this angle. Let me replicate that angle again. This is the downward force of mg, and this angle is already, we know that, 90 minus theta, and the other angle is this one. It creates 90 with the horizontal slope, and if this one is 90 minus theta, this angle, the remaining angle should be theta to complete it to 90. So this angle becomes 90 now, theta now. So now it is theta. So what is this force? It is nothing other than, this is the cos side of that one. I have already said that in previous lessons. Cos is equals to cos. Very simple, you can obtain that. So mg, so you can easily get it, this one, mg cos theta, and this downward one as mg sine theta. This is how you can resolve these forces along with that. Okay, shall I show you one simple example? Simple example is going to be 5 kg mass. So I'm not going to take it as 5 or any mass, just m. So your force is mg and the angle is 30 degree. And I'm just going to ask, what is the acceleration of this one? How to find out the acceleration? So as I mentioned earlier, it's a frictionless one, so it is mg cos theta. So r is not going to be counted because it has no friction. So the downward force is F equals to ma, that's according to the Newton's second law of motion, and the force which is dragging this one along the slope is going to be what? Mg sine theta, as we found earlier. The second one, mg sine theta, number 2. So how to resolve these two forces now? 1 and 2. So you are just going to link them together. MA equals to mg sine theta. So A is going to be g sine 30. Sine 30 is half, and you know that g is just 10. 10 by half, it is just what? 5 ms minus 2. You don't need the mass of it. So it's really simple. There are some other calculations. It may include very hard things. Don't worry, let's discuss most of these things in future. I will make more complicated videos in future, and subscribe to my channel. God bless you.